The iconic Great Red Spot of Jupiter may disappear in the next 20 years, according to a researcher at NASA's Jet Propulsion Laboratory in California. The massive storm, larger than Earth itself, was first spotted in 1830, and observations from the 1600s also revealed a giant spot on Jupiter's surface that may have been the same storm system. This suggests Jupiter's Great Red Spot has been raging for centuries. The storm's vortex has maintained strength because of Jupiter's 300 to 400 miles per hour jet streams, but like any storm, it won't go on forever. Jupiter's Great Red Spot, a gigantic storm more than twice the size of the Earth, has persisted for centuries. But now scientists predict it could disappear forever in as little as 20 years. A new NASA portrait immortalizes the dying storm on Jupiter's surface. The Great Red Spot is an ancient storm that's now about the size of Earth, but when scientists first spotted it in the 1800s, it was 4 times bigger. The reasons the iconic tempest is shrinking are still mysterious. Jupiter's Great Red Spot is an anticyclone that swirls around a center of high atmospheric pressure. It rotates counterclockwise, the opposite direction of hurricanes on Earth. Part of the challenge is that the Great Red Spot is peerless. There's not much in our solar system to compare it to. There's also the question of what could come next. Should the Great Red Spot vanish? If it really does disintegrate, could another like it form? No one knows how much time Jupiter's most memorable storm has left. It could be decades or centuries. But the end of Great Red Spot, whenever that might be, could signal the beginning of something else. Like its storms, Jupiter is perpetually unpredictable. Its chemistry creates chaotic beauty, randomly, yet routinely. In a 2018 study, a team of NASA scientists analyzed observations of the anticyclone from the past 140 years. They found that as the storm shrinks, the force of its contraction is pushing it upward, like clay on a potter's wheel. They also found that the spot recently started drifting west faster than ever before, and that its orange color has been getting deeper since 2014. That could be because the chemicals that color are exposed to more UV radiation as the storm is pushed higher up. "We believe this thing is really old," says Scott Bolton, principal investigator of NASA's Juno mission. How it lasts that long is a mystery. Before Juno, scientists could only observe the storm from afar. Even from a distance, they noticed it was changing shape and actually shrinking. NASA's Juno mission was launched from Cape Canaveral Space Force Station in Florida back in 2011 and arrived at Jupiter in 2016. In 2019, the spacecraft changed course slightly and passed over the Great Red Spot twice. Bolton and his team used microwave sensors to slice into the depths of the storm, getting the first 3D model of the Great Red Spot. It's a pancake because it's so wide at the top, but the depth of that pancake is much thicker than what we would have anticipated. The microwave observations show these storms on Jupiter, called vortices, extend below the cloud deck of the planet. In the case of the Great Red Spot, it extends at least 200 miles into the clouds of Jupiter, beyond the depths of where clouds form and water condenses. That's very different than the way we think Earth's atmosphere works, which is largely driven by water, clouds, condensation, and sunlight. During its 2019 pass over the Great Red Spot, The Juno spacecraft buzzed the planet at a blistering 130,000 miles per hour. The storm is so massive that its gravity field actually jostled the spacecraft during its flyby. It's impossible to predict the fate of the Great Red Spot. Even with our most powerful telescopes, we can't peer deep into the storm and find its roots. And no spacecraft sent to Jupiter has been equipped to fully answer this question. Despite the gaps in our knowledge, we can try to understand what the storm's past and present say about its uncertain future.